This is question number 2013 Kcse Mathematics paper 2. We are told the figure A, B, C, D, E, F below represent a roof of a house. AB is equals to DC. This is AB is equals to DC is equals to 12 centimeter. BC is equals to AD is equals to 6 centimeter. AE, this is AE is equals to BF is equals to CF is equals to ED is equals to 5 centimeter, and EF is equals to 8 centimeter. So those measurements have been indicated on the diagram. So part A, calculate correct to 2 decimal places the perpendicular distance of EF from the plane ABCD. So perpendicular distance is a distance from here to the plane ABCD. So what we do is we can draw a line here, there, which is to pass at the middle. Let's put it here. So that line passes at the middle, and then we drop a perpendicular line here, like that. We can label this part F, E, F, G. Let's label that this part point and this point H here. Now, since we are required to calculate the perpendicular distance, what do we know here? This side here is 5 centimeter. Now, if we draw another line here, let's draw another line here. Since we have EF is 8 centimeter and AB is the length is 12 centimeter, it means if we can drop another line here, another perpendicular line here, let's put it like that. What this means that is this is 2 and this is also 2 and this is 8. Now, to get the perpendicular, what we need, this is a right angle here. So we can use this side here because this is 3 and this is 3. So we can use 3 and 5 to get EH, and then from there we can use EH to get the perpendicular height. So we can come here and say, let's say we say EH is equals to the square root, because it is a right angle triangle, of 5 squared minus 3 squared is equals to the square root of 25 minus 9 is equals to the square root of 16, which is equals to 4. So it means that this side here is 4. If this side is 4 and this is 2, then it means the height that we are looking for, which we can say height is equals to, this is a right angle, so it is the square root of 4 squared minus 2 squared. So this is equals to square root of 16 minus 4 is equals to the square root of 12, which you can get using your calculator, and you'll be able to get 3.46 meters. So the height, the perpendicular height from EF to the plane ABCD is 3.46 meters. So that's how you work out that. The second part, so this is, we can say this is A. So let's come to B. We just use this, so we can just use here. Calculate the angle between the planes AB, the plane ADE. Where is our ADE? This is ADE and ABCD. So the angle between these two planes is actually this angle here. And since we have these measurements, we can say the cosine. We can say cosine of cosine is we say it is cosine is adjacent of a hypotenuse, is it cosine of let's call it theta, is equals to adjacent is 2 divided by 4 is equals to a half. So you use your calculator now and now get cos inverse of a half. So you press the inverse button, you press cos, that will give you cos inverse, and you put 0.5, and you'll be able to get theta here is equals to 60 degrees. So the angle here is 60 degrees. So that's how you get that. Roman number 2, the line AE. This is AE and the plane ABCD correct to 1 decimal place. So the angle between the line AE and the base, that is ABCD, is the angle between AE and its projection. So we can draw up a line here to represent the projection, which will come and touch that. So that is a projection. It will be, that is, if you drop E, it will fall onto G here. So the angle that we are required to find is this one. And how do we do that? We have already found this is 3 point. This is the square root of 12, which we have found is equals to 3.46 here. So we can use root 12. I've put root 12 so that, because this is approximated, so that we will be able to get a better or exact value. So we can say that angle, we use sine. Sine of this angle is opposite of a hypotenuse. So we can say sine, let's call it alpha, is equals to, opposite is root 12. You divide by the 5. You divide by 5, and when you get when you divide that, then you get it is 0.6928. So you can now get sine inverse of 0.6928, which you can use your calculator and say, you just say sine inverse, you press the inverse button and you write 0. Actually you can put the bracket and say the square root of 12 divided by 5, and you put the bracket, and that will give you the angle 43 is equals to 43.9, and this is to 1 decimal place, as we have been told here. So you get 2 marks by doing that. Then we have the plane. You get the angle between the plane ABEF. This is ABFE, this plane here, ABFE, and DCFE. So actually the angle that we are required to find here is this angle here, angle between that is angle the angle AE. So we can say what we say, since we can be able to calculate half of this angle and we multiply by 2, so we can say the tangent of angle, we can actually call it AEH. AEH is equals to, that is that angle, you multiply by 2 so that we get the whole angle, which you get, it is 2 multiplied by tan inverse of this angle, which we say it is tangent of this angle is opposite of adjacent. So you say it is opposite. This is the opposite, that is this is 3, and this is the height is 12. So what we do is we get it is equals to tan inverse of 3 divided by root 12, which you'll be able to get, it is 2 multiplied by 40, that is the tan inverse of this, 40.89, which you get it is equals to 8, these are degrees, 81.8 8 degrees. So the angle between these is actually the angle between the 2 points. So that is how you work out that question. You did this in Form 4. I think the topic known as 3 dimension. That is where you covered that in Form 4, and I hope you have followed. So you should be able to work out angles between the plane, angles two planes, angles between a plane and a line, and that should be easy for you.